Hello friends, welcome back to the video lecture series on control system. So today we will continue our previous lecture which is on block diagram. So in this lecture we will take some complicated block diagrams and how to reduce it and get transfer function we will learn. So in this block diagram, first step we just check whether there are any cascade or parallel configuration. So in this there is no parallel or cascade configuration. So definitely we need to shift summing or takeoff point to the left or right hand side of block gain block. So what we will do first, we will take this takeoff point to the left hand side of G2. So we just name this is a node and this is a B node. So we have to shift this A node to the B. So initially there is a effect of G2 on H1, but after shifting to the B, effect is not present. So we need to multiply H1 with G2. Then next is G2 and G3 are in cascaded due to this shifting of takeoff point to the left, and G4 is in parallel. So we get G4 plus G2 G3. So we have to minimize whole this circuitry into G4 plus G2 G3. Then next step is we need to shift this takeoff point B to the right hand side of this block. So initially there is no effect on this feedback. So after shifting to the right hand side, effect get introduced. So we need to just divide H1 G2 by G4 plus G2 G3. So we need to shift this B to the C. For that we need to divide H1 G2 by G4 plus G2 G3 like this. So eventually what we can get, G4 plus G2 G3 are feedback with H2 which is a negative feedback. So this get reduced into simplified block. Then these two blocks are in a cascade, G1 and this is simplified block also in a cascade. So simplified block for this negative feedback loop is this, which is cascaded with G1. So G1 get multiplied with this block and whole block is in negative feedback with G2H1 upon G4 plus G2 G3. Then at the end unity feedback loop we get. So transfer function is nothing but this is the final answer, y of s upon r of s. So this is a very simple sum. If we go step by step, definitely we get the answer. This is one more example. So there is no cascaded configuration or in parallel configuration. So definitely we need to shift takeoff point or summing point to the left side or right side of block. So here what we will do, this is node, we need to shift to the right hand side of G4. So A is the node and we need to shift to the right hand side of G4. So initially effect of G4 is absent. So after shifting to the right hand side, effect get introduced. So we need to divide H3 and H2 by G4. So here we just introduce 1 by G4 1 by G4 block. So those are in cascaded. So just simply we need to multiply. Then G3 and G4 are in cascaded, so we get G3 G4, and this is a feedback loop, negative feedback loop. So simplified block for this negative feedback loop is G2 G3 G4 upon 1 plus G3 G4 H4. So here we can easily get two different negative feedback loops. One is this and second is this. So if we convert into simplified feedback, we get this expression. Just substitute over here both expression. Then simplified block diagram is like this. So this is a simple negative feedback loop. So transfer function y of s upon r of s is nothing but this. So this is our final answer, which looks bulky, but same what I said earlier, if we go step by step, there is no chance of getting wrong answer. Next diagram. So here what we will do, we need to shift this takeoff point to the right hand side of G4. So initially there is no effect of G4, but after shifting to the right hand side, effect of G4 get introduced. So nullify that, we need to divide H2 by G4. So like this diagram we get. So there are three simple feedback loops we can easily recognize. G3 G4 feedback with H1, so this is positive feedback. Then G2 and simplified block reduction of this get in cascaded and feedback with H2 by G4, so this is negative feedback, and whole reduction is negative feedback with H3. So three feedback loops we need to solve, then we get y of s upon r of s answer. So same what I said earlier. So G2 and this simplified get cascaded and feedback with H2 by G4. So G1 get cascaded with simplified block, and last negative feedback loop. After solving this, we get final answer. So this is one typical sum from Ogata. It looks bit complicated, but trust me class, after doing two simplification, it is a very simple sum. So for that, one simplification is we need to shift this takeoff point to the right side of G4, as previous sum, as in the previous sum what we did, we just divide with G4 in H3 like this, and we need to shift this summing point to the left hand side of G1. So here before shifting, G1 effect is not there, but after shifting G1 effect is introduced. So to nullify that, we need to add in feedback loop 1 by G1 block. So like this. So after doing this two simplification, we can easily recognize this is a negative feedback loop, this is a negative feedback loop, and these two are in a cascaded, and one more positive feedback loop is there. So simplifying three feedback loops, we get C of S upon R of S. So this is the final answer. After simplifying three feedback loops, we get the answer. Now next point is very important. Superposition of multiple inputs means till now we consider only single input and single output system, but instead of single input, if there are multiple inputs, then what we will do? So step 1 is set all input except 1 equal to 0, means at a time on system only one input acts alone, all other inputs equal to the 0. So transform, then next step 2 is transform the block diagram to canonical form. So all the earlier sums we studied how to convert different block diagrams into canonical form. So according to that, just convert into canonical form and get the response. Then step 3 is calculate the response due to the chosen input acting alone. So by using 3 steps, we get response due to the particular input we can calculate. So repeat this 3 steps for each and every input. So if there are 3 inputs, then we get 3 different responses due to individual inputs. And at the end, step 5, algebraically add all these responses, we get total output of the system with all inputs acting simultaneously. So this is our aim which we get after adding all these response. So simply we take some example to understand these 5 steps. So here R and U, these are 2 inputs and C is the control output. So response due to R first we will calculate. So for that U must be 0. So simplified block diagram is G1 and G2 get in cascaded. So and this is a unity negative feedback system. So response due to R is nothing but G1 G2 upon 1 plus G1 G2 whole into R. Now next step is calculate response due to input U. So for that feed forward gain is G2, feedback gain is minus G1. So instead of minus G1 we will put G1 and positive sign get changed as a negative. So this is a simple negative feedback where feed forward gain is G2, feedback gain is G1. So response due to U is G2 by 1 plus G1 G2 whole into U. Now we have two different response. One is response due to input R and response due to input U. We need to just add these two inputs, then we get total response or total output. Next sum is similar as the previous sum what we did, exactly same manner we have to solve for 3 inputs. So instead of 2 inputs there are 3 inputs. So first R is acting on system, so that time U1 and U2 equal to 0. So we get response due to the R, then response due to U1, then response due to U2. So after getting all these 3 response, we need to add or apply superposition theorem. So we get total response is equal to response due to input R, response due to input U1, response due to input U2. So we need to add this, we get total response. Now next sum is very popular sum. Here question is determine C1, C2 due to R1 and R2. So first step is we have to ignore output C2. So we are calculating C1 initially, then we will calculate C2 by neglecting or ignoring C1. So here by neglecting C2 we get block diagram like this. So forward transfer function is G1, there are R1 and R2 two different inputs. So once again over here multiple input theory we need to apply. So at a time only one input is acting on this system, other input equal to 0. So here first we will calculate C11, that is nothing but response due to R1 signal. Then we will calculate C12, that is nothing but response due to R2 signal. So C11 is R2 is equal to 0, so we get simplified block diagram is like this. So C11 is nothing but G1, so this is a positive feedback system, so G1 upon 1 minus G1, G2, G3, G4 into R1, and C12 is nothing but response due to R2, that time R1 is equal to 0, so this is the calculated C12, and after adding C11 plus C12 we get C1. So output response C1 we calculated. So half part is done. Now for C2 we need to ignore C1. So here is also R1 and R2 two different inputs. So we need to calculate C21, that is response due to R1, and C22, that is response due to R2. So after calculating these two response we need to add, so we get C2. So in this manner we find C1 and C2. So thank you for watching this video. In the next lecture we will start with lecture 7, that is nothing but signal flow graphs.